right, welcome to the Unit 3 test review video. Starting with the first section, it asks us to identify and label the key features of the absolute value function graph below. First one is the vertex. So our vertex is always going to be the point on the V shape. So this point here is our vertex, and that point is at 3, -2, 3, -2. All right, the axis of symmetry is going to be that line going straight down the middle of our graph. And it is always x equals, that point is 3, so it is x equals 3. For the domain, all absolute value functions have the same domain, negative to positive infinity. And let's think about that. If you were to take your pencil, pretend this ruler is your pencil. Take your pencil. Because the domain includes the x values from left to right, we're looking at the x-axis, we move our ruler from left to right. And we see that the furthest left point here is an arrow. And the arrow is pointing towards negative infinity. And as we go towards the right, the furthest arrow is going towards positive infinity. So from left to right, our domain is negative to positive infinity. And again, this is for all absolute value functions. Now for the range includes the y values from bottom to top. So we take our pencil, look at the bottom of the graph, and we want to name the lowest point of the graph to the highest point of the graph. So our lowest point from bottom to top is right here at -2. And as we continue up our graph, it has arrows. It is heading towards positive infinity. When we write the range, our infinities always get the parentheses, and a point that is stuck in gets the bracket. All right, for the x-intercept, we look at the points where our graph crosses the x-axis. Here it is at 2 and 4, and these are points. So writing 2 and 4, this is not correct. They're not numbers, they're points. And how do we write points? We write them as 2, 0, and 4, 0. Okay. All right, for the y-intercept, where does our graph cross the y-axis? Well, it kind of cuts off here, but it looks like it's about to cross right there at 4. And when we write the y-intercept, we write it as a coordinate point. Awesome. Okay, moving along. Graph the absolute value function f of x equals the negative absolute value of x minus 2 plus 3. And then identify the key features. Okay, so when we graph an absolute value function, we first need to look at the vertex. The vertex is going to tell us where the graph begins. And the vertex is going to represent, or the points that represent the vertex, the values are h and k. And our absolute value function is written in standard form, which is y equals a times x minus h plus k. So this is the positioning of each of the values. Starting with h is added or subtracted to the x on the inside of the absolute value function. So here our h, it says it's -2. But one thing we know about x is that x lies about his friend h, who he's hanging out with. So if it says it's -2, we know he's actually +2. And the k value on the outside of the absolute value is 3. All right, now let's go ahead and plot that point, 2, 3. And the axis of symmetry. Well, okay, we'll get that in a second. Let's finish plotting first. So we have one point. Now we need to figure out where our other points are. So usually when we graph linear, regular straight lines, we use slope. Now in the absolute value, the a value in front is representative of our slope. So in front of the absolute value signs here, we have a negative, which means our graph is going to be upside down. And there's a hidden 1 right here. So that means our slope is 1. We can say A represents the slope. So if our slope is -1, we're going to go down 1, right 1. And that's where our first point is going to go. Down 1, right 1, down 1, right 1. And we keep doing that until we get enough points to make a line. Now we go back to the vertex, and because we know that absolute value functions create a V and not a straight line, we're going to go back to the vertex, go down 1, left 1. All the way. And we'll take our ruler or straight edge and connect the dots. There we go. All right, so we have our nice little absolute value graph right here. Now, to continue with our important key features here, the axis of symmetry, that's going to go right through the vertex. We say x equals, and it's going through the number 2, so x equals 2. And something I talked about also was that the axis of symmetry will always be the x value of the vertex. All right, the domain for all absolute value functions is negative to positive infinity. And the range, let's take our pencil, starting from the bottom to the top, because range represents the y from bottom to top. So from the bottom, from the bottom, we move up, and we see that our graph has arrows. So we know it's going from negative infinity. And as we raise, what is our highest point? Our highest point is at 3. So our range is negative infinity, comma 3. 3 has a bracket because it is an included point and it is a measurable point. In other words, there's not an open circle here. All right, the x-intercept, where does our graph cross the x-axis? Right here and right here. And that is -1, 0 and 5, 0. Now the y-intercept is right here at 1. We're going to say 0, 1. Now, this is here if you wanted to graph using the values, like calculating from each x value what the y value is, but this is so much easier just looking at the slope. So we're not even going to bother with that. Okay, moving on to part 2. I can describe the transformations of absolute value functions. Which equation represents the graph of f of x equals the absolute value of x, translated 4 units left, 1 unit down, with a vertical stretch by a factor of 1/2. All right, so let's talk about this. 4 units left. In our standard form, which letter represents left and right? H. If it says x minus h, we're shifting to the right. If it says x plus h, we're shifting to the left. So if it says x minus h, we're moving right. If it says x plus h, we're moving left. So right now it's telling us that we're moving left. And the one that's moving left is x plus h. So in our equation, we need to see x plus 4. Not this one, not this one. It's either C or D. Now, it also says 1 unit down, and K is the one that goes up and down. 1 unit down would be -1, so the only answer that matches what we have here is D. Now, the vertical stretch, they all have 1/2 in front. The vertical stretch represents A, and they all have 1/2 of their A values, so that's fine. Here it says, describe the transformation of the following function. So we have A is -3, H is +2, and K is 7. So starting with the A value, we have a negative. Negative means we have a reflection over the x-axis. Okay, the 3 is greater than 1. So since our A value is greater than 1, we are going to have a vertical stretch by 3. All right, and then we have H being 2. That means we are going to move to the right. Shift right. Oh, I keep forgetting the word right. Shift right 2. And the last one being +7, we are moving up 7. So those are the 4 transformations that are happening here. So just to reiterate, reflection is the negative. The vertical stretch by 3 is the A is greater than 1. The shift right 2, in the equation, it says x minus h, and the up 7, it says plus k. And again, we have A, H, and K. All right, let's go ahead and move down. I can solve absolute value equations. Solve the equation and state your answer as a set. All right, so we have the absolute value is equal to 4. Is this absolute value isolated? Yes. So we can go ahead and solve. How many solutions do we have? It's a +4. So we have a positive and a negative solution. Can I add 10 to both sides? All right, so here we got 4, 14, and 6. Graphing our line here. We put the smaller number first. Oh, just kidding. This is not an inequality, so we're not graphing the line. Woo, my bad. So when we write our answer, we're going to write the squigglies, put the numbers in the squigglies. All right, next. It says solve the equation and state your answer as a set. That's what that's saying. As a set. Set means squigglies. Think about that. SS, set squigglies. So first we need to isolate. Yes, it is isolated. So we can go ahead and start with our 2 solutions. I know it is 2 solutions because the 8 is a +8. We start by adding the 4. And then dividing by 2. Then we write our answers as a set. -2 and 6. All right, moving down. We need to isolate the absolute value. Our first step in isolating would be to subtract 2. We still need to isolate. There's still that 4 in front. So let's divide by 4. All right, now the absolute value is all by itself. It says the absolute value is equal to 1/2. 1/2 is a positive number. We can go ahead and start with our positive and negative solutions. On the negative side, the 1/2 becomes negative. We add the 10. And we can write our answer as 9.5, 9.5, or 10.5, and 10.5. All right, next one. Again, we need to isolate the absolute value. This one looks a lot like that one problem on your last quiz. How do we get rid of the denominator of 6? What's happening to the 6? The 6 is being divided. So how do we undo division? We multiply. The 6's cancel out, and now we are left with 4x minus 10 equals 30. All right, is this absolute value isolated now? Yes. So we can go ahead and move into finding our solutions. 30 is positive, so we're going to have two solutions. Add 10 to both sides. All right, so our two solutions here are negative 5 and 10. All right, moving on to the next section. Again, if this is moving too fast for you, pause the video. Take your time. Okay, so last part, I think. Just kidding, we have two more parts. Okay, this one says I can solve and graph absolute value inequalities. Solve and graph the solution set for the absolute value inequality. All right, so again, same process here. Is this absolute value isolated? No, it's not. We need to get rid of the 8 by adding it to the other side. Okay, 9 is a positive number, so we have two solutions, positive and negative solution. Now, when we work with inequalities, not only does the 9 become negative, the inequality flips. So it was less than or equal to, and now it is greater than or equal to. Moving into solving, we subtract the 4 from both sides. Our two solutions are negative 13 and 5. So let's go ahead and put those on the number line. Now, when we graph the number lines, we can do this two ways. We can read, if you are comfortable reading the inequalities, this one says x is less than or equal to 5. Well, less than 5 is going to be right here in the middle. And it also says x is greater than or equal to negative 13. So we're going to shade towards the middle here. Now, if you are not comfortable with doing that, and if so, that's fine. There's nothing wrong with that. Find something that works for you. And hopefully this little trick does. We look back at the absolute value once it had been isolated. Now that it's isolated, it is less than. And when we hear the word less than, we want to think less the and. Focus on the word and. The word and puts two things together, like mac and cheese, peanut butter and jelly, chicken and waffles. Those are all things that go together. So when we think less than, the and means we're combining in the center. The equal sign on that inequality means we're coloring in the circles. Okay, let's try the next one. Oh, well, I also need to write the inequality. So sorry. So writing the inequality, we're going to say negative 13 is less than or equal to x, which is less than or equal to 5. On the next one, we need to isolate that absolute value. So how do we get rid of the 2? We divide by 2. Why do we divide by 2? Well, because 2 is multiplying towards the absolute value, and we need to get rid of it. So now we are left with the absolute value of x plus 4 is less than 5. 5 is a positive number. So we are going to have two solutions. And on the negative side, we have greater than negative 5. Subtract 4 from both sides. And here we have x is less than 1, x is greater than negative 9. We look back at the sign when we isolated, and it was less than. Less than means less than, and that means we're going to be coloring in the middle. This inequality does not have an equal sign underneath it, so we are not shading in the circles. Just coloring in the middle. Now our inequality will say negative 9 less than or equal to x, less than or equal to 1. All right, next we have the absolute value minus 3 is greater than 8. Again, we need to isolate. How do we get this absolute value by itself? We add the 3 to the other side. Now that our absolute value is isolated, we can go ahead and identify how many solutions. The 11 is positive, so we're going to have 2 solutions, positive and negative. And on the negative solution, we flip the sign, and 11 becomes negative. We start solving by subtracting 1. And then dividing by 2. So our 2 numbers here are negative 5 and 6. Now we need to look at the inequality once the absolute value is isolated. Here it is greater than. And when we hear greater, we want to hear great or, which means we're going to be shading the 2 separate sides. There's no equal sign, so we are not shading inside those circles. When we hear great or, we think of 2 separate things, this or that, not 2 things coming together. All right, next one. We need to isolate the absolute value. How do we get rid of the denominator? It's being divided, so we need to multiply. 15 is a positive number, so we have 2 solutions here, positive and negative. On the negative side, we flip the inequality and make the 15 negative. Start by subtracting the 1 on both sides. And we get our 2 solutions, negative 16 and positive 14. All right. For this inequality here, we look back to when the absolute value was isolated, which is right here. And here we want to think this is less than. So less than, so and means to combine. And it has an equal sign, so we are coloring in those circles. All right, now I forgot to write the inequality for the last 2, so let's do that. Here it would be, oops, negative 16 less than or equal to x less than 14. And on the left, since it's or, we're going to write 2 different inequalities. X is, oh, I just realized I mixed these 2 numbers up. This is a negative 6 and a positive 5. So x is greater than 5 or x is less than negative 6. There we go. All right, moving on to the next one, last page. Now we need to write equations and from word problems and then solve them. So as a reminder, your formula is x minus the target, and it is always minus, and that is, then you put the inequality here, and the varies. So Teresa builds chairs for fun. Before she can sell them, each chair must measure 80 centimeters in height with no more than 2.5 centimeter error. Write and solve an absolute value inequality for this situation. All right, so when we're writing these, the larger number is almost always the target and the smaller number is always the varies. So let's write our equation. We're going to say x minus 80 and then leave a space for the inequality, put your varies 2.5. Now let's focus on the inequality. Here it says no more than 2.5. So when we determine the inequalities, we want to ask ourselves three questions. I'm trying to find some room. Three questions. One, that looks awful. One is, could it be, let's do this. Could it be less, more, or equal to? So in this case, our first question is, okay, could we have an error of less than 2.5? Well, it says it's no more than 2.5. So yeah, we could have an error less than 2.5. Could we have an error more than 2.5? No. Could it be equal to 2.5? Yeah, it didn't say that it could or could not equal 2.5, so it does. So we're going to say it says less and equal. Less than or equal to. Then we solve. And on the inequality side, we flip the sign and make it negative. All right, I'm going to let y'all solve that on your own, and then I'll come back and help do the graphing. Well, here, I'll tell you right now. This is a less than, so we need to color in the circles and combine. All right, for the next one, she's buying a black rug. She wants it to be 60 inches, give or take 3 inches. So here our target is the 60 and our varies is the 3. Now for the inequality, let's go ahead and set it up. X minus 60 and 3. Now it says give or take. Could it be more than 3? No. Could it be less than 3? Sure. Could it be equal to 3? Sure. So here we have less than or equal to. Positive and negative solution. On the negative side, we flip the inequality and make the 3 negative. Now again, we have less than, so we're going to have 2 dots colored in and combined in the middle. All right, these two are equations here. So you have money in your wallet, but you don't know the exact amount. When a friend asks you, you say that you have $50, give or take 15. So our varies is the 50, and no, just kidding, sorry. Our target is the 50, and our varies is the 15. It says give or take 15. So again, we're writing an equation. So x minus our target equals the varies. Solve for 2 equations and write your answer in a switch. For the next one, it says the average number of seeds in a package of cucumber seed is 25. The number of seeds in the package can vary by 3. All right, our target is 25, our vary is 3. There we go. Positive and negative solution. For the negative is negative 3. Positive is positive 3. Same thing on this last one that I did not write for you guys. And then again, write your answer in the set. All right. If you have any questions, please come to tutoring on Monday morning. Good luck and thank you.